Meso compounds. What is the difference between enantiomers, diastereomers, and meso compound? If you want to learn more about enantiomers and diastereomers, please have a look at the description below where you will find links to videos that explains all about enantiomers and diastereomers. Now we are going to talk about meso compounds. So when you have something like tartaric acid, this is a symmetric molecule that has two chiral carbon atoms. And as expected for any molecule that has two chiral centers or two chiral carbon atoms, we have a possibility of four different stereoisomers based on the different combination of configuration of the two chiral carbon atoms. So the first one, we would have the RR configuration or the RSS configuration or the RS or finally the SR configuration. So there are four possible isomers here. And we would expect, as when we explained enantiomers and diastereomers, that the RR and SS to be enantiomers and the SR with and the RS with the SR will be enantiomers as well, while when only one configuration changes, they will be diastereomers. However, for tartaric acid, the RR and SS are enantiomers. However, the RS and SR are not enantiomers. Actually, they are not chiral at all, and they are the same molecules. They are called meso-pair or meso compounds. So what are meso compounds and how can we identify whether or not our isomer is a meso compound? So a meso compound, when we have the RS and S stereoisomers, which are going to be super impossible on their mirror image, they are going to be identical. So this is the case for tartaric acid. So the RS and SR stereoisomers are super impossible on each other, so they are not enantiomers. They are the same molecule. So if you rotate the molecule 180 degree, you're going to have the opposite stereoisomer, which is going to be exactly the same compound. So they are super impossible on each other. These are called meso compounds. How can we identify a meso compound? A meso compound will have two things. The first thing is an even number of asymmetric atoms of opposite configuration. So this is tartaric acid. We have two chiral center, two asymmetric carbon atoms, and one of them is an R configuration, while the other is an S configuration. So first of all, there is an even number of asymmetric carbon atom of opposite configuration. That's the second thing, that they're going to have an internal mirror plane bisecting the molecule, which means that half of the molecule must be exactly like the other half. So as you can see, there is a plane of symmetry here, a mirror of plane of symmetry that dissect the molecule into two identical halves. So for any compound that has two chiral centers of opposite configuration and two identical halves, this is going to be a meso compound. So each half of the meso compound is the mirror image of the other half, and they will cancel the optical activity of the other. So half of the molecule will will rotate plane polarized light at one direction with certain value, while the other half, because it has the opposite configuration, same structure, is going to rotate the plane polarized light into the opposite direction with the exact same value,